Thanks to those who sent in their questions for our quiz review. This first one is solving two-step variable equations. So I'm going to draw my double bars. Remember, we are always going to get rid of the adding and subtracting first, and then the multiplying and dividing. So first thing I'm going to do is subtract 3 from both sides, and I have 2x equals 6. And then I divide both sides by 2, and I have x equals 3. Next question. 12 equals 7 plus x divided by 2. So I am going to subtract 7 from both sides. 12 minus 7 is 5. X divided by 2. Multiply both sides by 2, and I have 10 equals x. In this problem, we have to do the distributive property first. So I have 2x plus 10 equals negative 2. I'm going to subtract 10 from both sides. 2x equals, be careful here, that's negative 12. Divide by 2, x equals negative 6. Next problem. X divided by negative 3 equals 5, or minus 5 equals 1. So we are going to add 5 to both sides. X divided by negative 3 equals 6. Be careful, you want to multiply by negative 3. Don't forget that negative. X equals negative 18. Here we have 8 equals 3x minus 4. So we are going to add 4 to both sides. We have 12 equals 3x. Divide both sides by 3. 4 equals x. This next one here, we have 6x minus 4 plus x. So I would suggest that you combine 6x plus x and get 7x minus 4 equals 10. Then you can go ahead and add 4 to both sides and get 7x equals 14. Divide by 7, x equals 2. Now, would you get the same answer if you had added 4 first? Sure. If you added 4 here, you would still get your 14, and you would still be left with 6x plus x, which would give you your 7x. I just like to combine like terms first just to, I don't know, just make it a little bit neater to look at. Now, one of the questions I had was about multiple variables on both sides. I was unsure if it meant multiple variables as in the same variable on both sides or if it meant different variables. So we aren't going to have ones with different variables right now. So I just did them with multiple. So in this case here, I would combine 2x and 3x and get 5x plus 2 equals. Now here I can combine 7 and 3 and get 10. So I'm going to go ahead and do that. And I am going to subtract x from both sides. And I get 4x plus 2 equals 10. Then I will subtract 4x equals 8, and I have x equals 2. Now this is multi-step equations with variables on both sides, so this is similar to the problem that we just got done doing. And here I'm going to subtract 6x, so I don't have to deal with any negative variables. So I have 7 equals 13 plus x. And then I will subtract 13, and I have negative 6 equals x. Why I like doing it this way better is I don't have that negative x. If I had subtracted 7 from the other side, see if I can squish that in down here. Now I just erased the original problem. Hopefully it's still there when this finishes. So I'm going to solve it the other way, and I'm going to subtract 7 and I have 6x equals 6 plus 7x. Now I have no choice but to subtract 7x, and I end up with negative x equals 6, which dividing by that negative 1 gives me x equals negative 6. So my concern is that if you do it this way, that when you get to here, you'll forget that negative x, or you might forget to divide and make the 6 negative. This is why I moved the variables first by subtracting 6x. Let's look at this one here. 13 minus 4x equals 1 minus x. So I am going to add 4x to this side. 13 equals 1 plus 3x minus 1. 12 equals 3x. And divide by 3 to get 4 equals x. This one is a little bit longer. 7 times 5x is 35x minus 28 minus 1. This parentheses here, you're going to stop with your distribution. Don't continue. Equals 14 minus 8x. Now I'm going to combine 35x minus 29 equals 14 minus 8x. And then I am going to add 8x to both sides. And then add 29. And then divide by 43. This is probably as complicated as you'll see on the quiz. Here are just some random examples of problems that could trip you up. In a case like this first one here, I actually like to add x to both sides. And that way I don't have to worry about that negative x. And then I'm just going to subtract the 30 here. 18 equals, negative 18 equals x. Problem below. This is 3/8 equals p minus 1/8. It is not p times negative 1/8. This is why we always write the coefficient in front of the variable with multiplication, because this is actually a subtraction problem solved by adding. Add 1/8 to both sides. 4/8 equals p, which should be 1/2 equals p. Be very careful with a problem like this. 2/3 x equals 6. I'm not going to actually divide. I am going to multiply by the reciprocal. X equals, and then multiply across. 6 times 3 is 18, over divided by 2, which is 9. And this problem here, I am going to do the death to fractions and multiply everything by 12 over 1. And I will get 12 times 1. I'll actually just write the whole thing out. 12/3 x plus 12 divided by 4 equals 60 divided by 12. For those who can see the simplification, right here is 4x plus 3 equals 5. 4x equals 2 divided by 4. X equals 1/2. You can also still solve this last one by just changing everything to twelfths. Instead of 1/3 x, you could do 4/12 x plus 3/12 equals 5/12, and just subtract that way. Here's another good one. We have negative 2y minus 4 equals negative 2y plus 1. Now those of you might remember that we said if these are exactly the same, we're probably going to end up with no solution. But let's just see what happens. If we add 2y to both sides, these cancel out. And we're left with negative 4 equals 1. And that is not a true statement. So we end up with no solution. If you are right here and you recognize you don't need to take it down to there, just make sure you write no solution. We had a request for some basic integer facts review, so really quickly, 2 plus 3 is 5. Negative 2 plus negative 3 is negative 5. You can think of this as football, as money, as a number line. I am 2 to the right, and I am now going 3 to the right. I'm at 5. Here I'm at negative 2. I'm over on the left side. I'm now going to go 3 still to the left. Gives you negative 5. Here I am at 2. I am going to the left 3. I will end up at negative 1. Here I am at negative 2. I'm going to continue to go back 3, negative 5. And this tricky one here, these two will cancel each other out because they make an opposite, and we have negative 2 plus 3, which gives you 1. Now with multiplication. Multiplication and division have the same rules. Multiplication is just repeated addition, where really division is just repeated subtraction. So you also want to think of 2 times 3 as 2 groups of 3 objects. So you had your 2 groups, and you have 3 objects in there. You have a total of 6. On a number line, your 2 groups of 3 objects. So you have 1 group, and then you have another group, which gives you 6. 2 groups of 3 objects. Therefore, with 2 times negative 3, with repeated addition, it's 2 groups of negative 3 objects, or negative 3 plus negative 3 is negative 6. And then on a number line, because you're going in the opposite direction, it's going to give you negative 6 this way. Your rules for multiplication and division, if you just want to be rule-based, a positive multiplied or divided by a positive is a positive. A negative multiplied or divided by a negative also is a positive. But as soon as you have different signs, your answer becomes negative. So you can think of the number line. You can think of groups and objects, and just remember these rules go for both multiplication and division. So a little review. 2 times 3 is 6. 6 divided by 3 is 2. 2 times negative 3 is negative 6. Negative 6 divided by 2 is negative 3. Negative 6 divided by negative 2 is 3. Negative 2 times negative 3 is 6. Hopefully this will help.